Okay, Shrutika, yesterday you were present while creating a test bench for inverter like. So you can open library manager. Okay, you can go to tools, library manager. Yes, you can maximize this library manager. Yes. So whatever the library you have selected for your locate that library. Yeah, that only. Oh, so you haven't created the test bench, right? Have you created the symbol, Shrutika? Yeah, good. So you created this symbol. So one thing you need to do here, just create new cell view in this library. So go to file, new cell view. Yes, good. Click on that new file is ready pop up. Yes, good. Now here inv underscore tb, give the file name, cell name. Underscore tb. Yes, inv underscore tb. Good. tb, test bench. Yeah, good. Okay. Yes. Yes. Okay, just a minute. Okay, maximize the semantic editor. Good. And type I for instance. Yes, good. Now select your library where your symbol is present. Your library name. Shrutika. INV Shrutika. Good. Yeah. Now, yes. And take a, yes, CLN. INV underscore CLN. Not a TB. Okay. Cancel it. INV CLN. In that your symbol is present. Na? Good. Hide this and place your symbol. Yeah, good. Yeah, escape. Good. So now you take one pulse, V pulse source from analog lib. If you want to take any component type I instance, good. Analog lib, select the library. Yes. Here V pulse, type V pulse. PUL. Yes, good. Hide this and place it before the input. Before the input. Yeah. Good. No, input is A now, so that you should properly place it. Escape it now. Escape it. No. अरे we need to connect that to A terminal ना now that is your A. थोड़ा align कर लो उसको थोड़ा नीचे ले लो ठीक है let me operate your PC. So I'm telling like this, okay. Uh, okay, I will show you on screen how to what kind of diagram you need to create. You just copy that, okay.
Yes, sir.
कहाँ पे open किया है? कौन से यहाँ पे not clear yet. इससे नहीं है ना नहीं चेक कर लो ना यार इसमें फोल्डर नहीं बनना एक ही बनना फोल्डर डिलीट करेंगे उसको पता ही है वो डीसी सोर्स लेने।
Yes, Rutika, you just take the DC source in the VDD and as a VSS also. Okay, you have given the pulse, right? Okay, please wait. Are you hearing me?
Yes, sir.
Okay, fine. Just connect it. Just connect it. Move little bit and just do the connections and all. Here you have to another VDD source that the supply voltage is VDD equal to 1.2 volt. Oh, sorry, 1 volt. Here we'll take one pin as output. Right. Do the connection with the help of wiring. Yes, Poonam, you just open the test bench. Poonam, yesterday you have created, right? Go to your folder. Poonam, is your folder name is showing here?
Yes.
Where is your folder
No.
name? Okay, not. So you have to revoke it again. Wherever your folder name is there, from there you can revoke the tool again. Okay. I am just closing this tool. Just find your folder where you have created, inside which only you just have to open the terminal. See, this is for I think NAND, right? There is no any inverter testments showing here. Please wait. Yeah.
Sir, in
Where you have created yesterday? Inside only. Okay. Go inside it. Okay. Shrutika, one thing I want to tell you that see directly don't connect the VDD here directly. You just put a supply voltage, delete it. Just take one supply, just copy it. Not don't copy. Okay. You have to paste one VDC source. Now you take ground. Now you just connect it. Here you put voltage source as a VDC equal to 1. Now it is okay. Now do the connection through the. Yes, Puram, you have created here, right? Okay. Wait, I have to check it. See, this is the for only NAND gate, right? This you can see here. This is created for the NAND gates.
sir,
But I'm asking about
in the
the test bench.
I'm able to find it, sir.
Okay. Okay. Go back. Okay. Back one more time. Wait, I have to check it once. There to show the folder means it will show all whatever you have created. Let's say yes, inside this folder you have created, right? Please wait, I have to check it. Okay, inside NAND there is only NAND circuit as I am seeing. There is only NAND is there, no inverter. Hmm, one more I have to check it first. Okay, inside this only you are telling, right? Okay, we will check. We will check here. See in the last, if you have whatever the file you have opened in the last, it will show here, right? So like that, yesterday you have, yeah. See this, the name of this library is like inverter underscore Poonam. You have created like that. See.
Yes.
Okay. See here you have. Wait, I am opening this. Please wait. This is the TV folder, right? It will be opened from here also. Yeah, right. It is correct.
Yes,
Is it
sir.
so? Okay, okay. Just run it once. It is just run this. Run the ADL window. Go to ADL and run it. Check the transient. Yes, Mohammed. You please do the power analysis. do the power analysis as I have first day I have explained you regarding the power delay and PDP. Just do the power analysis first, Mohammed, for you. After that, we'll
Okay,
move
sir.
further. Okay, fine. Yes, Shrutika, what's problem you are facing? Okay, Shrutika, see, what we need is that we need to give a supply voltage, right? So what we do is that we'll provide a supply voltage to that of VDD and one pulse to that of input A. See, in spite of giving into the stimuli, we can give directly to this schematic view also, right? That two will the same only. Okay, you have deleted some. Hello, Shrutika, are you listening to me?
Yes, sir.
Okay, okay. See, you have deleted something like, see, this is the power source. We can directly connect it here so that the supply will means the ready supply will be getting from here, right? And no need to connect. And one more thing, please wait. I am showing you. Right, V pulse here. V pulse is nothing but the voltage means voltage in the form of pulse. V pulse. That I'm explaining you one by one. Just see my how am I doing. See, this is only the test bench. We have created a symbol and we are testing for that. See, this is the plus symbol indicates the positive voltage and the negative will be connected always to that of ground. So we will copy this one and we'll put one ground. Whenever you provide the supply voltage, there must be a positive and negative. The negative must be connected to that of ground. Here also you can see the negative terminal that will connect it to that of ground. If you want to rotate, you can rotate. Right. See, I have rotated. I have copied this ground. I have put it here. Now I'm doing the corrections. I will be explaining you one by one. If you want to do it again, I will undo it and you can do it again. I don't have any problem. Yeah. Now we'll go for check and save. See what I'm trying to explain you, right? That see, this is my input, right, Shrutika? And here we are providing a pulse waveform to that of input. And from VDD we are providing directly supply voltage to that of VDD to remain the circuit in operation mode. So we have provided a supply voltage directly to that VDD, and here we are taking the output. We can put one pin and we can name as light A, B, whatever you want. We can place pin here also with the help of some wire, but let it be. We need to focus only the output. We have to check, right? Now you can see that. Uh, where is your log file? Yeah, this one is your log file. The schematic is completed with no error. Alright, that means schematic is completed. Now you can just go to ADL and run this simulation. Oh, wait, Srutika. One more thing. I want to give the input here. I have just taken the pulse, right? But we have to provide this also. It's voltage 1, voltage 2, period, delay, rise time, hold time, and pulse width. Just provide the input here. Give the voltage level 1 as 1 volt, whatever you want. Voltage 2 as a 0. Yes, provide the input. Type there, yeah, good. Provide the period. No, don't apply. Again, you have to fill this, all this. Provide the period, whatever you want. 100 nano. Okay. Delay time. Don't give so much delay because you have a 100 nano pulse. Don't give so much delay because it will start after 50 nanoseconds. Let give us 10 nano. Okay. Delays delays means that what starting delay, what are the times that the circuit will take to start from that. So let it be 10. Okay. Pulse width 40 nano. Fine. Apply. Then apply. Okay. Okay. Apply. Okay. Okay. Good. Okay. Mohammed has done the simulation. Fine. Mohammed, do the power analysis. We'll check it. Okay. Shrutika, define this also. This define. Shrutika, go to proper define this as a 1 volt. This is nothing but a source that we are providing. Same thing only. This one is okay, Shrutika. You have updated. This regarding this. You just Go to the properties. Yes, go to the properties. Write DC voltage is equal to 1. Go inside that. Okay, go to properties. See, shortcut key is Q. Okay, write the DC voltage. DC voltage 1. That means the source that are taking 1 voltage as a power supply, right? Okay, apply. Okay. Now check and save. You have done the correction. You have to do check and save. Fine. Now go to launch ADL.
क्या चेक करने को? Okay. हाँ पूनम, open the AD.
Sir, my test bench file is
What? What happened?
test bench file is open, sir.
Yeah, good. Now we need to do the simulation now. You load your state, the previous state. In AD, load your previous state. Go to that folder like symbol. Folder like symbol. Next to save. Next to save, not that one. The last one. Yes. You can you can click on OK now. The bottom one. Yeah. Close this waveform. Okay. This virtuoso visualization analysis. Yes. Now the states are loaded. Good. Okay. Be here only. Okay. What is it? Poonam? You simulate it. Okay. Now you simulate it.
Sir, shall I run it, sir?
Yeah. Netlist and run. Netlist and run. Yes.
Sorry. Yes,
Yeah,
Ritika, you have done correct. Okay.
now
That is your input, right? Okay. Fine. You just need to load. See, extra. This is extra. You can delete. Right click and delete. This is not as such required. You delete this. Okay, fine. Yes, Ritika, go for the
Yes, sir.
power analysis. As I explained in the first class, that output save all, right? Go add power here, average power. Save all. No. Save all. Click on save all. Just yes, save it. This and this. This one. Right? Apply OK. Now you run this ADL again so that power will be loaded. Okay.
okay, Poonam, you can also do power analysis. Okay. Maybe two AD windows are open, right? Or only one is open? Poonam?
Only one is open now.
Okay. Okay. Now you can do the power analysis. On the first day, sir has shown, right?
Yes, sir.
Hello, sir.
Bolo na.
Sir, I have added the equation for average power from calculator, but when I'm simulating, I'm not getting the plot.
Okay. You just run it.
Okay, sir.
Okay, I will check Mohammed for you. Just run it.
Yes.
Okay, fine. Okay, from where you have gone to the calculator values. See, from here you have
Yes,
to
sir.
go, right? Tools.
Yes, sir.
Result, direct plot, main form, right?
Yes.
Okay, from here you have to go to the power. See, the power is specified, the transient analysis is not saved. That
Not
means you have
saved.
not saved, right? So you have to save
Yes.
it first. As I told you, go to output, save all. Have you done it?
Save.
See, you have not
Yes.
saved the power. If you will not save the power, it will not show. First, whenever you want to plot the power, you have to save this options, right?
Save all
So this
option.
you have to put save. Then only again you run, then it will show.
कुछ दिखा दीजिए पावर
Okay, okay.
भूल गए होंगे.
Okay, for please look my system. I am showing you how to calculate the power again. Just see it once, then you perform in your systems. Okay, please wait. I am sharing my screen. Okay, participants, I am sharing my screen. You can see my screen. बंद कर दो. Cancel कर दो. Okay, fine. Please wait. Are you able to see my screen? All of you, please look at once.
Yes, sir.
Okay, fine. Yes, Mohammed, are you able to see my screen?
Yes, sir. Yes, sir.
No?
Yes, sir.
Fine. See, I am just going to launch ATL. Asking for license, I am pressing it yes. If I have saved the state, I can load it from here. I can see the state is not saved. So no problem. I will do this analysis. Choose analysis. See, you can go from here also, or we can go from here also, right? So let's go from here. 500 moderate. So transient is being loaded. See, for saving the power means for for doing the power analysis, we have to save the output. We have to save the output. So we have to click on this output save all. You have to just save this transient. When you will not save this transient, power will be not plotted. So just keep it in mind that we have to go to option save all, and we have to save all these transients, whatever analysis we are doing, right? Then again I'm going to output to be plotted, select and design. Just I have selected my output and input and output. I'm going to my EDA. See, my output is being loaded. Transient, whatever analysis I want to do, that has been loaded, as well as I have done the save options, right? I've done the save options, that is select signal to output, that is whatever the signal will be plotted, that will save the transient data, as well as select the power signals, means power signal to the output, that also we have to do save. You have to check the checkbox this save signal. Now I'm running my simulations. Mohammed, you are doing that time correct, incorrect. Rectify it. Okay, fine. This transition has been loaded. So, and I'm minimizing it. For plotting the power, I have to go to result, direct plot, main form. Right? Go to result, direct plot, main form. Then you can see power. There is function tab, and under the function tab, power is indicating, right? So then we click on power. Whatever we want, let's say we want instance power. Let's say, what does instance power means? Let's say here n number of transistors there. Let's say any design having a 10 number of transistors, but I want only the how much power consuming in transistor number 4. Then we'll go to the instance power and select that instance only, and how much power is consuming that instance, that will reflect there. But the total power means that what the circuit, the whole circuit, how much power is consuming. Okay, we'll click on plot. See, we have clicked on plot. It will be plotted, I think. Yeah, you can see here total power plot has been plotted, but we want the average value of that. But we want the average value with the help of calculator. We do the average. One more thing, if you want to send this equations to that of ADL window, you have to click on add to output. You have to click on add to output. Then when I clicking on add to output, you can see in ADL window it will be loaded. Wait, I will showing you. As I'm clicking OK and run, the in the ADL window output it will be loaded there. Okay. Okay, it is not loaded. Fine. Please wait, student. Okay, no problem. We'll check it from here only. Go to yeah. Go to result, direct plot, main form. Okay, add to output. I have to click on add to output plot. Okay, it is loading. Yeah, power is being loaded. Now, as I told you in the first class, see this we have to right click, send it to calculator. Send it to calculator. There is an inbuilt calculator in this Cadence, so you can under the function panel various analysis are there, so we can perform many analysis under that, but we are focusing on only on power. So this is my data for the power. When you want to plot this data, I am showing you the data, how the data is look like. See, the data is look like this. This is nothing but the Excel sheet that at any instant of time how much the power is consuming. Let's say at instant of 185 picosecond the power is consuming like that. So you can see the this data at every instant of power it is been shown. We have run the simulation up to 500 nanosecond, so it is showing up to 500 nanosecond, right? And when you sum up all this you will find the total power. So we not I'm showing you this is the data here, right? And please wait, but we want the average of this data, so we will select average. See, whenever just I have selected the average is indicated here, right? Now if we plot, it will give the single value. See, if you don't put average here, it will plot for every instant of time. When we put average here, it will give a single value. That means take the average of all this data, right? So here we have got something like 604 nanowatt. I want to put this equation into my ADL window. So you have to click on this, send buffer to ADE output. Just click on that, it will automatically send this equation to that of your ADE window. I'm showing you, yeah, see the equation has been loaded here. See these equations, as I have clicked on add to output, that's why this plot has been loaded here, and this equation I have sent it from the calculator, it is loaded here. When you will run it again, it will show the value it here. Wait, I am running it again, it will show the value here. All of you please do up to here step. See, I am showing you once. See, the value is loaded here, right? So we want the value to be loaded here so that we can do the further analysis of this power. So up to here, I think hope all are clear. You just load this. You'll do the advanced simulation of that. This is the equation we have loaded in the ADL, right? So Shrutika, Poonam, and you, Mohammed, have you understood? Just do up to here. Then we'll move on to the next step. Just do up to here, all of you. Okay, fine. Fine, Mohammed is doing. Yes, Puna, you just do. Yeah, Srutika is also doing. Very good. All of you do. One thing you have to remember, you have to save this option. Go to option, save all. So please check. Before going to run, just save all. Good. Okay, Mohammed. For checking the power result, direct plot main form. Go to result, Mohammed. Result, direct plot main form. Click on that. Select power. Yes. Plot. Okay, fine. Your power is plotted. Just take the average of that. Sir, please look at that system and then just help it out. Yes, Sutika, you're just have you got the power? I am coming back to you. Please wait. Coming to you.
Yes, Poonam. First go to output. First go to output. Yes. Save all. Yes. Good. Now the first two options, select all. No, don't click OK. The first ones, like select signals to output. Yes, that one all and this all. Okay. Okay. Click OK then. Good. Now go to tools. No, result, sorry, result. Go to result, direct plot, yes, yes, okay.
Sir, now I shall run.
अभी डायरेक्ट प्लॉट में आपने ओके कर दिया, तो उसको उधर डायरेक्टली प्लॉट करना है, इसको भेजना है, कैसे देखिए?
Just move, you are done, right? Just go to ADA window, go to result, direct plot, main form. Here you have to select power, add to outputs,
And plot.
see the plot has been plotted, right? Now you send to calculator, take the average of that.
क्या हुआ इसका?
हाँ power में गया.
हाँ,
Total power, total. No, don't instant power, total power. Select total power, add to output, then plot. Plot, click on plot. Okay, take the average of that.
now you click on that signal and send to calculator, okay? Shrutika. Yeah, good. Now in the search bar, yes, good. Now you can click on that besides rectangular, yeah, good. Now you can go to the ADE.
Check the buffer, how much value it is drawing. Okay, fine, no problem. Whatever the value.
Okay, now you can go to ADE, Shrutika. Yeah, good. So now you can run it and it will show you that particular power, okay? Yeah, good. So that value is will be shown in the ADE, okay? So this power is generally if you talk about any small circuit, so there are two types of powers, okay? First one is a static power and second one is a dynamic power. So what is mean by static power? When we don't, when the input of inverter is either 1 or 0, okay, in the stable state, if the inverter operating on 1 logic level or 0 logic level, okay, those are the stable state. So for those state, if you talk about the P MOSFET and N MOSFET, generally those MOSFETs are capacitors, right? Okay. So what happens due to the leakage current? So different parasitic gate forms when you fabricate the MOSFET. Okay. So there are different leakage current present in the MOSFET. So those leakage current will contribute to the static power dissipation. Okay. So this is the first element. And the second element is dynamic power dissipation. So what is meant by dynamic power dissipation? If I switch or if I switch the input of inverter from 0 to 1, I say, okay. So here we are giving a rise time 10 nanoseconds, hold time 10 nanoseconds, okay. So what happens uh, when that input is traversing from 0 to 1, okay, so it is not traversing sharply, right? So there is a 10 nanosecond delay. If you see the waveform, I will just show you the, okay. So when the input voltage of the inverter is VDD by 2, at that time what happens? PMOS and NMOSFET, those two transistor gets on, okay, at a time. And because of that, what will happen? The current will flow from VDD to ground, okay, and that will contribute to the short circuit power dissipation, right? And another thing is in dynamic power dissipation, for example, now you are creating a chip. Okay. Okay. Now, when you are creating a chip, for example, and I want to add another inverter, you may have seen the ICs where 2 and 3 inverters are present in same IC, right? So, for example, if I want to add another inverter into this IC, or if I want to create a buffer, what you will do? You will connect another inverter to this inverter, right? If you want to create a buffer. So, what happens? What happens when MOSFET is having some input capacitances? Okay, so it will act as a load to this inverter. If I connect another inverter to the output of this inverter, the next inverter input capacitances will act as a load to this uh, this inverter. Okay, so that capacitor with those input capacitances will get charged and discharged. Okay, and that will also contribute to the dynamic power dissipation, and that is a 90% of the total power dissipation. Okay, that's switching. And similarly, this inverter is also having some output capacitances. Okay, so when you study the RC model of CMOS circuit, so you can get the idea for that. Okay, so that power only we are calculating here.
We are calculating the power, right? So we have done up to here. We will see the advanced simulation. See, we will check only for the power first. Then we move on to the next, that is delay and PDP and all. So let's move on to the advanced simulations. See, this is very much helpful. Hello, Mohammed. You have got the power, right?
Yes, sir.
Okay. Okay. Let's see my screen first. I am doing my simulation. Just follow me. Then you, after just my completion, then you will try. Okay. Please wait. Are you able to see my screen, right?
Yes, sir.
Okay, fine. Okay. Okay, power is loaded here, like 892 point something like that. Some are getting 889, no problem. Whatever the power, the value is loaded here, right? We don't want to plot it again and again. I've just unticked it. I need the value this. Now go to launch, go to ADXL. Launch ADXL, then create new. You can perform parallelly also. Go to launch, all of you can perform parallelly. Go to launch ADXL, then create new. Yes, Poonam, go to ADL window. Don't go from here. Shrutika, yeah, ADL window. Just open your ADL window. Okay, okay. Please wait up to here. Poonam, go to ADL window first.
Poonam, that AD is bottom, at the bottom.
At the bottom, Poonam.
That window is at the bottom. Yeah.
Okay. Poonam, go to launch ADXL. Launch ADXL.
Launch the first, not there. In AD window. In AD window launch is there.
Other, please wait. So
Okay, let me operate. Let me operate.
Launch ADXL. Click. Okay, create new. Click on create new. Okay, fine. Now click on OK. Don't change the name. See, the name is showing here. Your library name is showing here. Cell name is showing here. View is ADXL. ADXL is used for advanced simulation in Cadence. See, ADL is used for only for the simulation purpose of basics like transient, AC, DC, and all. But ADXL is used as the advanced version of simulation, right? So don't change it all. Just press it OK. Just press it OK. One new pop-up window will occur. One new tab is occurred. See, inside this tab, you just maximize it, that tab. Just maximize that tab. Okay. Okay, fine. See, inside this, you can see the test, global variables, parameters, corners, right? As well as you can see here run summary. Here is 1.3 corners, nominal corners, and all. See, whatever we have given in the AD, that has been loaded here. You can see that I have ticked only for average power. In the ADL, we have put the output net as well as input net, and we have put the power, but we are focusing about the average power we want to vary. See, what we'll do, we will do the corner analysis. Corner analysis is nothing but there are total 4 types of corners are there. Like the name of the corner, that fast corner, fast slow corner, slow fast corner, and slow corner. That what the name suggests that, let's suppose we have in the inverter we have a PMOS and combination of PMOS and NMOS, right? In the first what has happened that when let us take the transistor that are having a speed of operation is fast, means faster operation. We are taking the transistor as such, like they are operating in a very fast response time. What will happen, right? And in the fast flow, that means your PMOS is fast and NMOS is slow. And in the slow fast, that your PMOS is slow, NMOS is fast, and in the slow, both the transistors are slow. So these are the four different corners that will test the circuit. That at four different corners, how the circuit, how the output power is behaving, how the output power is changing. So click on this corner plus tab. You can see here plus tab is there. Click on corners. Right? All of you, please click on corners. Click on corners, right? See, whenever we have not selected any corner, that means it will perform only for nominal, that is nominal value they have calculated. Now click on add to corners. We want to add four different corners. Click on add to add corners. Click to add corners. Just below the nominal you find, just below the nominal you find. Very good. Okay, all of you created. Okay, fine. Now there you in the upper tab you find that add new corner. See this, just take your cursor here, you will find add new corner. You press it four times. We want to add four different corner. We have pressed it for four times. See, C0 is the first corner, C1 as a second corner, C2 as a third corner, C3 as a four different corner. Means four corner we have selected. These are the tabs. Okay, all of you have selected. Very good. Now this one is my first value, that is giving me the nominal value. That is, let it be there only. But we want to first we have to add the models files. We have to add the models file. Click on add models files. Wait, and click on add models. All of you gone up here. Okay, click on add models, Rutika. Here you can see model files. Click to add. Done. So click on models file. Here you can see in this tab first column parameter model files. There is model file just below it in the model files. Click on created. Okay, fine. So click on models. Poonam. Okay, fine. Please wait. Okay, done. Up to here, all of you done. See, now you go to import from test. Import from test. See, our model file has been imported. Model file has been imported. You see the path: home, install, foundry, analog. This is the path of this model files. See, whenever we are running the circuit, there must be a model files that to support that file. See, this is the model files has been loaded. This has been loaded from the ADE window. Previously, that we have opened that window. From there, it has been imported the test. Now click on import from test. All of you click on import from test. Okay, fine. Okay. And then no, sorry. Click on OK. Click on OK. Click on OK. Okay, very good. Now you can see the model files has been loaded. You can see the model file name as gptk90. Just see the name gptk90.scs. All of you getting? See this, what does this model file suggest? What does this model file suggest? That we are using the foundry, we are using here gptk90 nanometer technology. So we have to call first model files. So model files gptk90.scs has been loaded here. Now click on this. In this third column, you find C0, C1, C2, C3. Just tick it. Click the checkbox, and from the drop-down menu, you will find different performance. But we need to focus only four different columns. We will select in the first column. Just see my screen. In the first column, we are selecting fast first. In the second column, we are selecting fast slow. In the third column, we are selecting slow fast, and the fourth column we are selecting slow. See, these are the four different corners that we want to perform our analysis, and we will check the how the power is varying for four different corners. you find the problem. All of you got it?
You double click on section, okay? There only. Shrutika,
See,
double click there.
Poonam
Yeah,
checking
drop
for
down. Yes.
Poonam has got, okay. Okay, fine. All of you have got. See, we have to go for 4 different corners. You can find there different types of corners is there. See, beside FF, there is FF of high performance. We do not bother for high performance. We just bother for 4 different corners that are fast, 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 slow, fast, and slow, slow. See, when you in the ADL window, previously we are going for the nominal analysis only, right? Now we are moving for 4 different corner analysis. Now just click on apply, okay. Click on apply, okay. See, in the left panel, you can you can find that all the 4 corner has been loaded. C0, C1, C2. You just expand it. You will find that what does C0 suggest? With C0, inside C0 we have put it fast first. Inside C1 we have put it fast slow. Inside C2 we have put it slow fast and slow slow. You just expand it. You just check it. Yes, Poonam, expand this corner. Just check it once. Okay.
No, for her it's not showing. Okay, Poonam, have you selected that slow, fast, fast, slow while
Sir, I
creating?
have only selected for last one, sir.
Okay. You have not selected. Oh, no problem. Just go here. Double click on that. You'll find. Poonam, do by your own. Poonam, do by your own. Okay, double click on that. No, please tick it. Please first check box, then double click here. Just select. Yes, Poonam. Fast slow. Very good. Okay, select the second one. Fast slow. Okay. Double click on that. Poonam, double click on that. You click outside first. See, now you double click here. Now all the 4 corner has been selected. Apply. Okay. Right. Now you can see 4 corners has been selected. Right, Poonam? All of you can see the four corner has been selected, right? Now we'll go for simulation. There one green tab is showing here, right? Run simulation. One green tab is showing here, run simulation. Click on that. In the left panel, you can see your running is going on. See here, running 0 by 5. Please wait. It will take time. It will take time because 4 different analysis we are doing. So it will take time. Total we are doing 5. One for nominal and 4 different corners, right? Press OK. It is not any problem. Press OK. What is the message showing? Following test variable were not found. Okay, you have not. Please wait, Poonam. You have not imported the test, I think. Please wait. I have to check it once. Have you imported that text?
Yes, sir.
Okay, why it is showing error? Because mine is running. I have to check it once. Please wait. Okay. Okay, it is loaded. Okay, fine. Run it. Check it is. See, whenever the error will occur, you always check the log file. In the log file, you will find what type of error it is showing. See, in this log file, wait, Puram, I am telling you. In the log file, see error. You read this error. Expression is where found the following variables. Oh, you have used some variables in your circuit. Don't use variable. You have used variable B, right? I am showing you where you have used the variable B. You can find it here in the inside circuit. Have you put it somewhere V? Okay, you don't want DC, right? Don't want this. You have to check it first. Go to the circuit. Where is your inverter circuit? Oh, this one is a circuit, right? Okay, we have to check it one by one. We have put it here something like V. Okay, this is okay. Yeah, see, this is wrong. This is wrong. You have put it right. I don't tell you to put V. It will automatically take V, right? If you put any variable, it will not run, right? So check it.
Yes.
Run. Check it and run it. Save and check and run. You have to do the same process again because it is first you have to run for AD, then only we go from AD to ADL, right? AD to ADXL. We are running it again. We have to check it first. No error is showing. I hope plot has been plotted. Okay, yeah, plotted. I think. Yeah, plotted, not error. Yeah, see, plot has been plotted. Okay, but fine. All the things are not. No, sir. No, I have not. I have not. I have unticked. See, I have ticked for power. That's why it is plotted for power. If I tick for all this, that will plot all this. You can see. I'm saying, yeah, fine. Okay, Poonam. Now, where is your ADXL window? This is your ADXL
Yes,
window,
sir.
right? Okay, we are running. Okay, it will showing same error. You have to generate it again. Okay, please wait. Again generate. You have to again go for ADL. Please wait. This I am crossing it. Okay, fine. This is okay, right? Up to here you are clear. Just go to launch ADXL. The same process you have to repeat. Create new. Okay. Okay. Oh, I have opened already existing file. Please wait. Click on create new. Okay, they asking for already exist. No. Do you want no? But do you want to overwrite? Yes. Okay, fine. Okay, fine. Now we don't want output to be plotted and this only one place this value will be plotted. So we have click on this, click to add corners. First we have to load the model files, right? You have to load the model files importing from test only. You'll find this model file here. Okay. Now you have to add some corners, 4 corners. Click on that checkbox. Other, please wait for 2 minutes. I'm coming back to all. Okay, fine. See, I have selected all 4 corners, right, Poonam? Then okay, you can find it here. You find all these 4 corners has been added, right? See, now we are running. It will taking time. It's fine. Okay, I'm explaining what are the output we have observed. I will explain you all of you. Yes, look at my window. Look at my screen. See what is happening here. Yes, Rutika and Mohammed, just observe this. This data is see in the nominal case we have found it like 892 nanowatts, something like that. And this C0 is your fast corner. In the fast, it will consume more power when the performance of PMOS and NMOS both are in the fast mode. It will consume larger power. That's why the power has came in the microwatt. That you can see that 1.5 times power has been increased. Earlier it is near about 900 nanosecond. This is somehow like 1.314, that is 1.5 times power has been increased. Why? Because we have chosen the transistor like that are operating in the faster region. In the fast slow region, we are getting near to about nominal value. That is nominal values like 892, we are getting 853 nanowatt. In the slow fast, that means our NMOS is fast and PMOS is slow. At that time, we are getting the power at 788 nanowatt. And in the slow, both the transistors slow. That means we are getting the power below than that of nominal. Right? In the same way, you have to go for the delay as well as PDP. You just analysis. See, this is the maximum minimum value they have calculated from these 4 data. They have given the maximum minimum value. So this I have shown you the how to do the corner analysis. we have selected 4 different corner. We have checked the power performance at how the circuit is behaving. You can see that the power is either lacking behind or leading behind to that of nominal values, right? So based on the transistor performance, the power is changing, right? So we have observed that the power is just ranging in between the nominal value, something above than that of nominal, some are low than that of nominal. So these are the power analysis we have done at 4 different corners. Now you, from your side, I wanted you that just go to EDE and you just load the equation of delay. From there you can again go to the ADL window and you just check for 4 different corner how the delay is changing. This one I have shown you for power. Just go for delay. Sir, please explain.
All of you. So what you do now, sir has shown you how to do the power analysis, the corner analysis for the power parameter, right? So similarly, there is a delay parameter, right? So there is a rising time delay and falling time delays are there, right? So first you what you do, first you calculate those delays, okay? Take into AD. After that, similar process what sir has shown for AD Excel to calculate the corner analysis. You need to do that, okay? So first, what you can do, the first step is uh, take a delay equation in your output variable, okay? After doing that, do the simulation, check it properly, and then launch AD Excel from the ADE menu only. So first, all of you do that step, calculate delay.
You can close the ADXL window. You can close the ADXL window. Go to the AD window. Very good. Okay, fine. Poonam is doing. Mohammed is also doing. Sutika, okay. You can close this ADXL window.
Yeah, good, good.
Good, good. Do.
Do you know how to calculate the delay, right? Now you don't change the sources. All the sources are setted down. DC voltage, ground, all these things are setted. You just need to calculate delay. So for that purpose, what you need to do? you launch ADL. Okay, here. Go to ADL. Now you need to calculate delay now, right? So after calculate, what process you will follow to calculate delay?
Sir, adding the
So,
cursors.
uh, cursor is just for visualization. You need to send the signal to the AD, right? Those
Yes, sir.
uh, those input and output signals, right?
Yes, sir.
Just wait. Yes. What you can do, you click on that particular net and then you send it to your what calculator, right? No, no. On the left hand side, there are nets, na net 5 V out. Yes, you click
Yes,
on
yes, yes.
that. Yes, yes. Poonam, you run this simulation. You run this simulation. Don't copy. You run this simulation. Yes, good.
Yes, sir.
Now, maximize this screen. Maximize this waveform screen, Poonam. Okay. Now click on that out net. Click on that out net. Good. Yeah, yeah. Click. First click. One time you click, then right click there. There only you should right click. Send to calculator. Yeah. Good. Now how you calculate delay?
Sir, adding the delay
You
function
use
from
the
bottom.
delay function, right? Uh,
Yes, sir.
Yes, sir.
yeah, yeah. Click the delay function then. Good.
Yes,
Now select the signals properly. One signal should be what? The
net
input
5.
signal. Other signal should be what? The output signal, right?
Yes, sir. Yes, sir.
Yeah, yeah, yeah. Right. Good.
Slash net 5 it should be.
Yeah. Shrutika, what you do? You go to so up to what steps you have done, Shrutika? Yes, yes. Okay, Shrutika, you do you open that waveform virtue. So the bottom one. Yeah, good. So that equation is there only. Yes, you can delete it, no issue. First, where is your waveforms? Okay, you can close this calculator also. You can close this calculator. Yeah. Uh, Besides, on the bottom window there is waveform. Okay, waveform. Besides AD, right hand side. Yeah, yeah, good. Okay. Now click on P is your output. P is your output. Okay. Click on that. Right click. Send to calculator. Yes. Good, good. Now you calculate delay function. You just search for delay. Good. Now one net should be what? Now the output net is selected there. Now you need to select the input net, right? So you can copy paste the signal one. No, no, that equation. Yeah. Here, from here also you can copy. No issue. Overall, you need to select it. Yes. Control C. Paste it in control signal 2. And what is your signal 2 net name? Instead of B, give that net name. Okay. Similarly. What happened, Poonam? So
Sir, calculator file is not finding.
calculator is not open. Here you can see on the virtue. So here. Okay.
Yes, sir.
Now you have selected. Now check the other things properly. Yeah. Okay. Now what you can do after selecting all these parameters, first we need to apply, right?
Yes, sir. Then buffer.
Yeah, good. Okay. Okay, now you can send this to your AD. Good, good. Shrutika, where was you? What net you select whatever the input net or what you have selected. Okay, that is a net 3, right? So instead of P, put net 3 there. Good. And it is a case sensitive, huh? So if there is a small case, you should type here also small case. Instead of P, Shrutika. Yes. Good, good. After this, what you can do? Good, good. You can click on apply. Okay, okay, good. Now you can send this expression to AD. How you can send this? Good. Now check your AD. Yeah, good. Can run the simulation. Yeah, good. Check that if AD is having that particular value. Yeah, good, good. क्या है इसका AD? Poonam, to close this, what you do, you just run this netlist and run. And that green symbol, yes. Yeah, now it's showing the value of delay. Close that. Close that. Yeah. Close it properly. Yeah, good, good, good. Now be here. Be here. Okay. Yeah, Shrutika, what you do? ठीक है, ठीक है, ठीक है. Okay. Good. Keep name as it is. Good, good. Now Mohammed, where are you? Here only. Have you connected to your system?
Yes, sir. I have attached the delay equation. Now,
Yeah.
how to calculate that PDP?
Yes. Go.
Okay, PDP you want to add. Okay.
अरे delay के लिए बोला है पहले आपने corner analysis.
Sir, hello. First do for delay
Yes,
corner
sir.
analysis, then we go for PDP, right?
Okay, sir.
Just do go to ADXL and do.
Yes, sir.
Okay, fine.
Yeah.
Sir will guide.
Sir, we to hello.
Who is speaking?
Yes, sir. Sir, we have to save all and then direct plot.
No. Click on OK. Now you click on OK. Yeah.
Then ADXL.
Yeah. Here only. Yes. 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 Overwrite. You can overwrite. Yeah. Okay. Now here, you haven't closed the previous window, I think, right? Get overwrite. You close this window, AD Excel. Wait. Shrutika, you wait. Cancel it. नहीं उसको टेस्ट बेंच फाइल और एक्सट्रैक्ट करना पड़ेगा ना पहले टेस्ट.
As you have, while doing that, you have not overwrite something like that. That means the previous data has been loaded. No problem. You can add it from here also. Wait, I'm showing you. Oh, that means your power expression has only been loaded. Okay. We'll just close this. We will launch it again from here. Launch. See, you don't want this plot. You just untick whatever you don't want. We want only for average power and delay. Launch ADXL. See, if you open the existing file, that means what are the previous one that has been uploaded. You have to go and click create new. Okay, then ask for overwrite. You just overwrite it, yes. Now you can do the rest process I have shown you. Just do click add corners and do add the corners first. 4 different corner add it.
The upper one.
Upper one.
That.
Yes, yes. Click 4 times. 4 times click. Now you add the model files first. Yeah, click on that. Yeah, very good. Import.
Yes. Click to
Okay.
add corners. Click on that.
Now first check
Sir,
the unbox. Yes, take that. Okay, fine. Select all that corners. Double click on that. Yeah, very good. Okay, I can see Mohammed has got the output. Very good. Fine. Okay. Yes, Rutika, run it. Okay, then run. Yes. Okay. And run the simulation. Green button is there. Yes. Please wait. Right. It will take some time. You can see the simulation is going on this side. Yes. You have found the value. Yeah. You can see that the nominal in the nominal case in the ADL window we have found 467, but in the case of first corner, that is fast, we are getting 531 picosecond, then 1.15, 186 and 424. Okay, we have got 4 different value. Okay, see, we always, all of you, we always go for the corner analysis because whenever we go for the fabrication purposes, it may happens that some transistor working on the high performance, some are low performance. So we need to always check the performance at 4 different corners, that the whatever the value of the nominal that are ranging means near to nominal value, or somehow sometimes greater than nominal, or some are below the nominals. Okay, fine. You have got, okay. Poonam also got the all those 4 values. Okay. Okay, we'll move on to the next simulation. That is Monte Carlo simulation. I want to use to show. Uh-huh.
Okay. So what is mean by corner analysis? Okay, we have seen that fast, slow, slow, fast. Okay, slow, slow. All these things are there, right? So generally, the MOSFET is having some output resistance. Okay, so when you are operating any load, okay, so at the output side, if there is a capacitor, right? So to charge that capacitor, as we know, there is a time constant RC. So in that time constant, R component is there and capacitive load is there. Okay. So if the MOSFET output resistance is very low, so what will happen? Time constant will be low. Okay. So that capacitor will charge fastly. Okay. And our circuit will operate fastly. Okay. So why we are doing this? That generally the resistance of the MOSFET is depend on the width of the MOSFET and length of the MOSFET, right? Okay, so those are the physical dimension of the MOSFET. We are designing by putting certain width and length. Okay, so we are designing that kind of thing. But what happens after the fabrication? Okay, due to the fabrication manufacturing variations, right? So there are manufacturing variations. These dimensions are very small, right? In micrometers, nanometers. So due to the manufacturing variation, what happens? Width get changes or some material get deposited. Okay, like that means width variation will be there. Because of that, what happens? For some transistor, width maybe get changed. Okay, suppose for example, while designing the MOSFET, I have set it the width 2 micrometer. Okay, but due to the manufacturing variation, what happens? That width will become 1.9 micrometers, like that way. Okay, so like that way, what will happen? Resistance will get changed. Okay, if resistance will become lesser, transistor will become faster. Okay, if resistance will become larger, transistor will become slower. Okay, so before the fabrication, we we are testing all these things. So why we are doing this? Because if you design your circuit and your circuit get fabricated, okay, and it is not giving the better performance, right? It is not giving the optimum performance. So all the costs which you have used to fabricate that particular IC will go into the waste. Okay, so for that purpose, we are analyzing our circuit and we are testing our circuit in a such a way that all the delays or the power analysis, all these things should be set to the optimum value. So we can do our design changes in that particular way and we can produce the optimum chip. Okay, thank you.
Okay, fine. Okay, fine. Thank you, sir. As sir has explained, I hope all have cleared that why we are performing that corner analysis, right? Now we'll move on to another type of analysis that are also comes under the advanced simulation part. That is Monte Carlo analysis. We'll go for Monte Carlo analysis. So all of you have loaded the data for average delay, something like that. Sorry, delay and average power. So just go here, go to Monte Carlo sampling. Just perform parallelly with me. Go here, select Monte Carlo sampling. Fine. Then go click on this setting window, setting tab, simulation option. Sorry. Click on this tab just beside the Monte Carlo sampling. Click on this tab that is simulation options. Okay. Poonam.
Poonam, you select that Monte Carlo analysis. So the top window is there, na? Beside the run, all those things here. That single run switch and corner window is there, right? Single run switch. In that drop down, you click Carlo. On the left hand side. Yes, there. Monte Carlo.
Right. Okay, fine. Yeah, Monte Carlo sampling. Now, just beside that, there is setup output. Setup output. Click on setup output option. Just beside that. Yes, Poonam, I'm showing here. Yes, just click on this. Right, please wait. I'm explaining this process. See, Monte Carlo is nothing but the statistical analysis. It will give the statistical analysis of our value of whatever you want to plot, like average power. What are the statistical analysis of that average power? That means mean or standard deviation. It will, when let's say we are running the samples for 500 samples, let's say 1000 samples, and what are the range of that sample that I'm showing you, then I will explain what is the use of that Monte Carlo analysis. Here, yeah, this statistical variation press in all, by default it is in all only, and the number of points let us decrease to 100 only, because it will take more time to simulate. We are doing for 100 samples, so we have taken the point as 100. Just change it to 100. Done. Okay. Say process data. Okay, fine. Then press it. Okay. Then press OK. Now we wanted to plot only for the nominal value. You just untick the C0, C1, just untick here. We don't want to plot C0, C1, C2, C3. We just wanted to plot for nominal. Just tick for nominal and untick all these corners. Why I'm telling that it will take more time to plot all this. So we'll check only for the nominal first. If you want, you can go for different corner also. We have checked for only for nominal. So all done. Please untick the all these corners. Okay. Okay, fine. Now you just click on run button, run checklist, run simulation. Click on green button, run simulation. Okay, we will wait because it will take time. See in the left hand side, it is showing running, right? Mine is running. What first sample is run, second, third, fourth. It will take time to run 100 sample. That's why we have checked only for the nominal values. After that, we will check. If you want, you can check for different corner also, but it is used only for the nominal. You can check this. Okay. Okay, we are waiting to simulation to be run complete. All of you running is going on. Okay. Okay, fine. Okay. See, it will give a histogram. It will give a histogram plot. Histogram plot. There it will shows the mean as well as standard deviation value, that how much your value of average power is being deviated from its mean values as well as standard deviation. I will show you the with the help of graph. Whenever it is simulation will complete, it will show the histogram plot. Okay, those simulation has been finished. Please wait. We will plot the data. Okay, 1, 2, all simulation has been finished. Okay, okay, follow me. See, uh, in the upper tab, you will find that histogram tab is there. That is some in this tab. That is the used for post processing operation for Monte Carlo. Right, click on that. Select your whatever the library name it is showing. Right, click on histogram. All of you follow me. Click on histogram. Then select you want for average power or total something like that. It is showing what we will choose for average values, right? Average power, average delay, whatever you have taken. Just click on select that average value. Click on plot. See, histogram plot will be there. Okay, fine. Everybody got the histogram plot. Okay, okay, fine. Right. See, in this histogram plot, we can see that we have run for 100 number of samples. We have run for 100 number of sample. We have find the mean value is 897 nanowatt, and in the nominal value of power we have got 889. But here, by running the 100 samples, the variation is very less. That is 897 nano, and the standard deviation, as you can see, that 142 nano. You can see that in the significance of that, it give the statistical analysis that how much our power is deviated, how much our delay is deviated to that of mean position. This mu indicates the mean value. This sigma indicates the standard deviation. 2 sigma, 3 sigma, that is standard deviation in the second order, third order, and all. So you can see that the histogram plot, and this solid line indicates the average of that values, average of that every instant they have taken. So all of you got the histogram. Okay, fine. You have to one thing remember that the mean value, whatever the mean value you have got in this histogram, that are related to that of whatever you have got in the nominal value, that are very much least deviation. Means in the our case in the nominal, you can check it into aerial. In the nominal value you have got 889. Here we are getting 897. Okay. Please wait, sir is explaining more about that. See, yeah, all of you have got the histogram plot. As I have discussed just now, whatever the value you are getting in the nominal, in the statistical analysis, the mean values near about to that of same value, right? Okay, fine. Okay. These are all about the advanced simulation in Cadence, that we are performing the Monte Carlo analysis, we are performing the corner analysis, different types of analysis we can do in Cadence, right? These are all has been done for the, whenever we go for the fabrication part, we must check the advanced simulation on that, that the circuit is performing well in the advanced simulation or not, that we must check on that. That's why we have shown the one or two data. For that you can do more parameters also, you can vary more parameters. Mhm.
Okay, so those who have done for power, they can do for delay. So generally, what is mean by this Monte Carlo analysis? Okay, so it is one kind of statistical analysis. The same what we have done the corner analysis, right? So it is also showing the process variation in the like if there is a chip, right? And if there are 18 transistors, for example, so while fabricating, all 18s will not be identical to each other, even if you design like that. Even if you have even if you have kept the same width and just a minute. Okay. So even if you keep the same width and length for each transistor, due to the manufacturing defects and process variations, those parameters will not be the same after the manufacturing, right? So some parameter, for example, if I am talking about this histogram, so if I talk about the power histogram, so here it is showing that mean value, it's showing that some value, particular value for that analysis, right? So mean value means most of the transistors, okay, most of the transistor will be having that much of power dissipation, okay. So we have done this for the inverter. So if there are 10 inverters or 12 inverters, so most of the inverters will be having the mean power dissipation, okay. And some of the inverters having low power dissipation, some of the inverters having high power dissipation, okay. Like that way, that dispersion will be there, okay. So what should be the our aim while designing any chip? So our aim should be that this dispersion will be very low, okay. So that that dispersion should be very low. Have you understood? So whatever the dispersion you are seeing now, so that dispersion should be very low. So most of the parameter, most of the components which are on most of the uh, blocks on that chip, on that particular block, will be having the same power dissipation, okay, or same minimum power dissipation. Have you understood? Means the sigma of this curve should be very low, okay. So while designing your chip, you should be careful for that. So for that purpose, we are doing this analysis, Monte Carlo analysis, okay, statistical analysis. So here you are seeing the samples, right? So how many samples have you selected?
100 samples, sir.
Yeah. Now what will happen if I select 1 billion samples? What will happen? Have you studied normal distribution? Suppose if there is a Qualcomm processor, okay, Qualcomm Snapdragon processor. which are mostly used in the cell phones, right? Okay, that particular processor is having around how many transistors in millions, right? So if I say, for example, if there is a 1 million transistor in that particular processor, okay, so what you think, what will change to this graph? What do you think? You just you just uh, just analyze it. Is other fellow listening, or they are just
Sir, mean value will get changed.
what about the dispersion, standard deviation? Okay, ठीक है. So this is about that only. Uh, so maybe the Poonam is not there, I think. Okay, ठीक है. Shrutika and Mohammed is there. So Mohammed has done this Monte Carlo analysis for power, and this Shrutika has done Monte Carlo analysis for power also. So now you can do this for delay, and you just check it. Okay.
Okay, sir.
Yes, Mohammed, you check for delay and you are done for power check for delay, right? See, as we increase the number of samples, what will happen? This you can check and you can find the mean value. As we increase the number of samples, the mean value will come closer to that of nominal value. If you can find it, as
Okay,
we
that
increase.
means it will decrease. It will
Yes,
decrease
it will
mean
decrease.
value.
Yes, it will decrease. Or this, you
Okay.
can see this dot value indicating that 100 samples means this value. What are the at 100 and what are the value we are getting, and it is plotting the mean of that all. This histogram. Okay, you can check for increasing the number of samples also. You can check it, but go for
Yes.
first. You have done for the power. You just check for the delay. How much is varying from the nominals. Okay. Okay, as I'm seeing the screen, yeah, Mohammed has done, Sutika has done. As you have done the for the two input NAND gate in the previous design day yesterday, you just open the two input NAND gate, you check the performance of two input NAND gate, you do the advanced simulation of that two input NAND gate and check it. And in the second half, we will going for the PVT variation analysis. That is nothing but the process variation temperature. We are checking it in the second half. We will check for that. Are you able to listen me? For the time being, for next 1 hour, you just do the practice for NAND gate that you have done yesterday. You just practice that. You do the advanced simulation of that NAND gate. You perform the corner analysis as well as this Monte Carlo analysis for the NAND gate, like average power and delay. Just in the same way we have done for the inverter. Just follow the same for the NAND gate. You just close this tab. You just open the previous one that you have performed yesterday and do it.
Okay, sir.
Okay, fine, fine. Yes, Shrutika, you also. Just close this, go to the
Yes.
NAND gate and do the same part for the NAND gate. Okay. Okay, fine.
Yeah, save the state before, but don't close the ADE. First, save the state. Then you can.
Sir, I've already closed it, sir.
Okay, for NAND gate, in which folder have you created? Only that folder you go, and then it will show you that particular thing.
Save it, Shrutika. Save it. Yes. Okay, fine. Just close it. Go for NAND. Practice the same.
Yeah, Muhammad underscore live. Have you done in that library?
No, sir, I've created a new library, sir. Separate folder.
So it is not that. यही था ना ये नहीं था क्या?
Yes, sir.
हाँ वही से ओपन होगा ना फिर वो बैक बैक जाओ या बैक जाओ जहाँ पे लिब है ना तुम्हारी लिब वाली फाइल है वो वाली में हाँ
Yes.
ये फ्रॉम हियर यू कैन हाँ यस यस ओपन करो टर्मिनल यहाँ से ये आपकी से भी आ जाता है हाँ ठीक है गुड यहाँ पे अभी टूल्स लाइब्रेरी मैनेजर को जाए या गुड मोहम्मद अंडरस्कोर लिव या राइट क्लिक ऑन दैट schematic you do हाँ Shrutika, while pressing the up key also previous command will come. No need to type again and again. Okay? Yeah. Do the up key, Yes, good. Enter. Good. Good. Yeah. The previous file is open, I think. You should close that. The previous, from the previous folder you have opened the Cadence. Before close that before, okay? Okay, so let me operate you for you. Okay, I will close all these things. So here only have you created or not? Means have you created in different folders, Kritika?
Yes,
This
sir.
Yeah, this one. Shruti 123.
Yes, sir, this one.
Yeah, here only you can open. No issue. Yeah, good. Okay. Now perform all these analysis for this. Okay, Shrutika, 1 minute. What you have done? Okay. डायरेक्टली स्टिमुलस दे रहे हैं क्या आप? ठीक है, यू कैन गिव स्टिमुली डायरेक्टली. ठीक है, डू हाउ यू डू इट. Yesterday you have done this transient simulation na, for 2 input NAND gate.
Yes, sir.
Good, you can do. Shrutika.
Yes, sir.
So you have sent it Y signal to calculator, okay? So what you want to calculate means you want to calculate delay.
Yes, sir. I am done with power and now I am going for delay.
How you are? Can you show me the power analysis? What you have done on AD window? That may be the visible. What about the power? No. That is the average of Y signal, na? Right? So for the power analysis, what you need to do? Y signal is what? What is your Y signal? That is output, right? So you need to do the power. You need to calculate the power first, and then you need to take an average of that. So how we do that? Now first what you do? You select that average signal. Select average. Yes. Now click on that delete. That cross symbol. Yes. Yes. Good. Now what you can do? You want to calculate the power, right? For the power analysis, what we do? First we go to the outputs. Not there. Yeah. Save all. Yeah. Save all. Yes. Good one. Okay. That is okay only. Now go to tool. Results. Yeah. Power. Yes. Total power. Add two outputs. Okay. Yeah. It may show now. You can show in AD. It may show. Yeah. Good. Now if you do the simulation here, it will show you. That window may be appear maybe. No. Besides that, close this. Close this. Yeah. Okay. Good. Now what you want to calculate? Average power. So what you can do? You can send this signal to calculator, right? And then you apply average function. Yeah. Now check your calculator. Yeah. Send it the signal. Besides that. Yes. Good. Now you can apply average. Good. Yes. You can close it and send to the output. Yes. Good. Now you can check your AD. Yes. Good. Is it showing in AD? Just check it. Yeah, it's showing in AD. Good. Average power it's showing. Now what you want to calculate now? Yeah, you want to calculate delay, right? Now for delay is the different process now. What we do, we send input and output signal to calculator, right? First we send the output signal and then we copy the same expression to. Now here two inputs are there, right? Two inputs are there. Yeah. With any one input you can perform, no issue. But that is also like ठीक है, you send first a signal. Good, you can send a signal. Yes, now you can check your calculator. You can close this, okay? There will be the less windows. Yeah, good. Okay, so the next thing what you can do, copy paste. Just you can copy and you can paste it into signal 1. You can change the net name. Check it what's the net name there. Yeah, output net name. Why? Yes. Now in the waveform, check all these means how those signals are related. Like, okay? Is it inverted or is it same? In the waveform, you need to check. Virtuoso. Yes. You check once. Split those signal first. Yes. Yeah. Good. Now check the relation between A and Y. So where you are getting rising edge, where you are getting falling edge. Okay. It's just like an inverted kind of thing, right? Okay. So you can do that thing. Yes. Yes. Yes, yes, yes. Now you check AD after clicking on that. Otherwise, it will get multiple. Yeah, yeah, good. Yes, you got all these values. Good. So what you can do now? You need to do the corner analysis and Monte Carlo analysis for this. No, no, don't close it. Take it. Don't close the AD now. Okay. So what the next step is? Yeah, good. Yeah. So what happens? All the signals are there. Good. Now what is the next procedure? Just try to remember it. No, no. What's the next procedure? Yeah. Yes. Good. Good. Okay. Now you know the previous. Double click there. Okay. You can select the transistors then. What about you, Mohammed? What happened?
Hello, sir.
All things are good. Have you calculated delay?
Sir, I've added the equation of the delay, but it's not getting evaluating. I'm not getting any value into it, sir.
Okay. So have you selected input and output while calculating the delay?
Okay, sir, I will show it once again to you, sir.
Okay. Check. Now check the relation between A and Y, okay, in your waveform. How means is they are inverted or how they relation? Okay. Now you can
Sir,
do.
A is rising and Y is falling.
Yes, yes, yes. Good, good, good. Yes, you can apply there. Go to the calculator. Yes. Okay. Just wait. Just run it. Just run it. Okay, it is not showing that.
Yes, sir.
Yes. Oh, evaluation failed. इसने क्या क्या सही से नहीं डाला, चेक करना पड़ेगा. Hello Mohammed, you have given the expression correct, right? You have
Yes,
to
sir.
check it. You have to check it first. You have given rise time, fall time, and all. Okay.
Yes, sir.
Okay, we will check. Please wait. This is right. See the threshold value you have given like 2.5, something like that. Okay. Threshold value is much higher, right? That will specification will not meet. As I told you, specific threshold value should be changed. Okay, I'm loading it again for you. Please wait. Where is your output? Think this one is your output, right? You want to see the delay with respect to A or Y? Which you
Yes,
want?
sir.
You want A and Y. Okay, fine. So you can select any signal. Let's say we are selecting A. Send to calculator.
Calculate.
हाँ थ्रेशोल्ड वैल्यू तो सब पूरा एक्सप्रेशन लोड करना पड़ेगा. यहाँ पे देखिए एक्सप्रेशन चेंज हो जाता है ना, इसलिए प्लीज वेट. आई एम शोइंग यू. Only you have to check the threshold value, right? Please wait. I have given the signal A as a first signal and Y as a second. I am giving. Please wait.
Second signal.
Okay. Small y or capital Y you have taken, right?
Capital Y. Capital Y.
Okay. Please wait. Okay, fine. See, threshold value have to change. As we have given the highest value as a 1, right? Our VDD is 1. It cannot go up to the value of below than means higher than that of 1. So we have to give certain threshold value. Let's say we have given the threshold value 0.5. That means 0 to 1. In between them we have given. And you can take the first stage as 1 and 1 only. Fine. Rise and falling. You just check it. A is rising or falling. A is rising. Fine. And
A
Y
is
is
rising.
falling.
Y is
Okay,
falling.
okay, fine. Periodicity 1. See, just need to clear this one. Just need to clear this one before sending it. Okay, fine. Now I will sending apply. See, the equation has been loaded here. Now click on this.
Yes.
You'll find the value. Is it?
Oh. Yes, sir. Yes, sir.
What mistake you have done? Have you understood?
Yes,
अरे
sir.
मोहम्मद
Threshold.
क्या होता है कि ये जो वैल्यू कैलकुलेट करते हैं ना अपन, वो
हाँ, sir.
50% थ्रेशोल्ड वैल्यू मींस 50% ऑफ योर मैक्सिमम वैल्यू, जो 50% राइजिंग एज का और 15% फॉलिंग एज का. तो क्या होता है, लो हाई टू लो डिले होगा आपके आउटपुट के हिसाब से. TPLH बोलते हैं उसको. ओके.
Okay. Okay, sir.
हाँ. You can also calculate TPHL, that is high to low. उसका फॉलिंग लोगे, इसका राइजिंग लोगे. ओके. उसको भी वही
Okay, sir.
आएगा 50% से. हमने थ्योरी लेक्चर में पढ़ा है वो. मे बी यू हैवंट अटेंडेड. ठीक है.
Yes, sir.
हाँ.
Just send it to calculator, send it to ADL.
Okay, you close this and send it to ADL. Okay. Okay. Now, those who have completed this Monte Carlo analysis and corner analysis, okay, Shrutika, maybe Mohammed is doing it's going on Monte Carlo analysis. Okay. So now I think that you are very much familiar with the flow, like that means how to create a cell, how to create a library, how to create a symbol for this particular kind of thing, right? And then how to do the ADL simulations. So all these things, all of you are aware now. Okay. So uh, so you take any design, okay. So whatever you want, you take any design. Similarly, I will just show you how to save this kind of thing, and you can also study this visualization window or any AD window. Means you check those things, how it will get reflected on your waveform. For example, if you want to save the image, okay, file, save image. You can save these images. Okay, so whatever you have done. So all these things you can check. Okay, like that way you can be familiar with this kind of tool. Okay, and you can also check that, for example, you have created this gate. Uh, if you want to create any design of your choice, you can create. You just need to start from the basic cell creation and doing all those simulations if you want to be familiar with this flow. Okay. So Mohammed has done, Shrutika has done. Take any design which you want to design. Okay. So and follow all the flow for that. And the next session we can start from 2 o'clock. Okay. Here also you can play with this Monte Carlo analysis means by just by changing the number of samples, how those means are getting varied. Okay, how those values are getting varied. Means, is it close to nominal value or not? You can check that kind of thing also. So now you can do the practice. Whatever design you want, you can create. Okay, so do the practice more so that you will be familiar with this tool more. Okay, so do the practice now.